All right. I am relatively new to Nemours. So this is kind of touching a little bit on some of my previous work and some of the work I would love to at least get some wheels spinning for some people internally within Nemours to start looking at. So I would be happy to help. And so my name is Abby. I'm a manager of research data and analytics. And please don't let the title of this lull you to sleep. I swear it's fun. So I'm here to discuss the intersectionality of multifactorial causality, geographic information systems, or GIS, and data governance. So the first concept that I kind of wanted to discuss here is multifactorial causality. So um, within research, this is probably not exactly a new concept, but something that I think is pretty important. So similar to the statement that the mitochondria is the powerhouse of the cell, most people who have taken some sort of statistics course or some sort of, read some newspaper recently have stumbled upon the phrase correlation does not equal causation. And that is very true. But it's kind of one of those statements, just like when people say mitochondria is the powerhouse of the cell, they're probably not going to break down ATP stuff for you. And just like this, they're maybe not going to break down causality. So this is kind of the tip of the iceberg in epidemiologic theories and approaches to multifactorial causality. And just if you don't want to remember anything else, just think about multifactorial causality is nothing happens in a vacuum. Multiple things need to occur for an outcome to happen. So this is kind of just in a brief overview, and I think someone recently mentioned Hill's causal criteria. It's 7 or 9 uh, kind of criteria that need to be met to establish causality. And then there's other different approaches for visualizations and to look at relationships and associations. And one is the direct acyclical graph, or DAGs. This is essentially, it will look like a spider web a little bit. And I have a visual
Mhm.
of that a little bit later. And then one of my personal favorites is Rothman's causal pie, which is considered a component cause. And this became particularly relevant during COVID. So it's also highlighted over here on the left. So you have 3 pies here. And at the top, there's 1, 2, and 3. And these all represent sufficient causes that could lead to an outcome. So, um, way back when I was learning about this, I'll give the example of people were concerned about groceries and getting groceries delivered and figuring out, were they going to contract COVID early on in the pandemic from their groceries. So, uh, in order for something like that to happen, it would essentially need multiple things to occur. Just touching that cardboard of your grocery box or something along those lines wasn't going to necessarily cause you to have the proper viral dose to contract COVID. So each of these letters represents a certain situation. So, for example, um, all your groceries maybe would need to be delivered in a metal box because it was a non-porous surface where COVID could live a little longer on it. And then on top of that, you would have to, for example, you'd have to touch that surface and then touch your eye, or touch your nose or your mouth. And then, and another example of that is maybe you recently were coming off of a cold. So all of these circumstances made you susceptible and could have potentially led to the outcome of you acquiring COVID from your grocery delivery. But it's one of those situations that um, this is an example of kind of an extreme, unlikely situation. But each of these things can, if you're looking at this, can impact the outcome of a health situation. And then the last model of causality is counterfactual models. these are probably a little more dense in regards to information. And so I'm just going to highlight it and say that it's commonly used to identify confounding when you're looking at an exposure of a situation and the outcome. All right. So then data governance. This is kind of a topic that I think a lot of people like to run from because it is kind of dry. Um, and but it's extremely important, and this is maybe not the key part of the example I'm going to present later, but something that I think is pretty critical to always have established when you're doing anything with data. So the main thing is it's the structure and internal policies that an organization or a group uses when they manage access and secure data. And these are things that you should be able to establish and answer, even within your own data for data governance. Is who owns the data? Who's the business owner? Who is the SME? So subject matter expert for the data. This is extremely important when we want to look at collaboration with multiple entities. So you want to have that direct line. You want to know exactly from that data set or that data grouping who knows it the best and who's going to be able to help you find the exact information that you need. And then there's also other aspects of data governance. So just because the data is there doesn't always mean you can use it. So sometimes there are certain registries and things like that that are never allowed to be used for research. They can be used for surveillance or quality improvement, but not research. So these are things that you need to know because one, you don't want to go to publish or go to present and realize you're not even allowed to share the data. You kind of violated some policies. So this is why it's good to have this clear cut. And the SMEs will come in handy a lot of the times too, because they'll help you kind of decide on the data that you'll likely need, because they'll help guide that concept of the data informs whatever decision, and not that you're coming in and you have this preconceived notion. The SME for that data set will likely be able to help facilitate and give you the data and help you with it without having an assumption prior to going in and seeing things. All right, so this is the fun stuff. So this is GIS systems. So this is a technology that is it's being utilized a lot more for visualization, particularly when disseminating information back to the public and policymakers as well. And it can help create, manage, analyze, and map all types of data. And this is particularly important because part of Nemours' concept is well beyond medicine. And that concept looks at the fact that 80% of your health outcomes happen outside of the clinical setting. So the GIS systems allow us to look at population level information, but also environmental information that could potentially impact health. So they allow you to map. It allows location data and descriptive information. So then we can establish, where are events happening, where are certain health things happening, and then also, why are they happening? Are all of the asthma hospitalizations right near the highway? They live right along the highway, and it's a bad PM 2.5 day. So that's just an example. And then on the bottom left, for anyone from Florida, I included kind of an example of what a GIS system can do in regards to presenting rates of diabetes hospitalization by census tract level in Florida. And then over to the bottom right is kind of a very, very basic spatial analysis of social vulnerability index and percent vaccinated and census tract level within Delaware. So the darker it is, the more vulnerable the population is and the fewer people vaccinated. So this actually informed some public health intervention. All right. So with all of that, there are some key things when you're looking at using GIS systems and looking at population information as well as clinical information. So when you're doing spatial analysis, there are certain assumptions that can occur. So there's location fallacy, and this essentially is People move. We are not a sedentary population, and sometimes exposures can occur outside the home. So, for example, in work and school, the air quality can impact. So that's something we need to take into consideration. Modifiable area unit problem is a very important aspect of geospatial analysis, and it's something that I'm going to show you guys in just a little bit. And then essentially that is depending on how you shape your data, it can change the entire outlook and can change the entire analysis. For example, modifiable area unit problems, policy and voting um, areas is a pretty good example of how this can shape and change the outcome of whatever situation. And then last but not least is the ecological fallacy. And so that's when you're looking at population or aggregate data. This is just this reminder, you cannot assume anything about an individual who lives in a certain census tract or certain zip code just because it's showing that a large portion of that population in that zip code has asthma. You can't assume that an individual then would have asthma in that community. And this is where clinical data comes in. And this is my really quick example. It's very hard to try to explain this all. A lot of my previous work that I did with the state is not information I can share. So there are some really cool examples of cancer investigations, as well as water contamination, different environmental assessments in regards to health outcomes, but I can't technically share those. So I pulled an example with asthma ER visits. So again, nothing happens in a vacuum. This is a DAG. And essentially what you'll be able to see here is there's environmental factors that lead to ED asthma visits. So there is healthcare access, but there's also air pollution, traffic density. Are they near a toxic release location and things like that, as well as, your typical social factors such as income and educational attainment. So this is my example that I think will be helpful in illustrating this modifiable area unit factor. So within the census tracts, this is a visual of the Environmental Justice Index, and these are areas where the threshold of PM 2.5, which can exacerbate asthma symptoms, and ozone, which is also known to kind of increase asthma hospitalizations and severity. This highlights in which census tract is ozone worse or has violated the threshold versus PM 2.5. So if you look up towards, for those who are not from Delaware, this is Wilmington. This is roughly around where the AI campus is. And so PM 2.5 from this visual likely would tell you, yeah, this is not great in this area. But that's not exactly the full picture here. So this is where it matters with how you visualize the data and how you use the area around it. So now this is showing you, this means around this area, yeah, PM 2.5 had above threshold within that census tract, that location. But the size of it indicates the frequency of days that were above that threshold. So this shows you here that there were a lot more days where PM 2.5 was higher within this area. And within Newark, for example, over here, ozone was a lot higher at a more frequent rate within that area. And this is also data governance side of things. This is pulled from the known source of truth, which is the EPA and the CDC. And then this, similar to these here, you'll see there's the density over here and over here. Then we begin to look at asthma. And this is asthma prevalence as well as socioeconomic status and household characteristics that make people more vulnerable, according to the CDC and ATSDR. And you can see asthma prevalence, the darker it is, the higher susceptibility and asthma, just crude prevalence. So that's here in Wilmington and over here in Newark as well. So then this is where you can then overlay the data. So you'll see there's a lot of times in which those with higher asthma prevalence, they're also experiencing, higher days with PM 2.5. So this is, for example, if you're in the clinical setting looking to do research, sorry, I know I'm running long on time. This is just an example of maybe a target area that you would like to overlay data with. So you can then pull data for childhood asthma hospitalizations, and you want to look at where their home location is, then you can map it on here. And this would then allow you to kind of circumnavigate a little bit of the ecological fallacy, because you're using individual data in tandem with this population aggregate data. The population data can help kind of narrow down exactly where you should be looking. And then you could then do an analysis, a multifactorial causal analysis, to look at proximity to highways, days above PM 2.5, even the day, like a temporal analysis within the Wilmington area, where you could look at the day individual went into the ED for asthma. And then you could also look at the PM 2.5 levels for that day and the proximity. So it's just, there's a lot of capabilities within this. And I'm kind of hoping that this will maybe spur some people on, and hoping that they will take some interest in using GIS systems to look at the whole health approach.